Hello and welcome back to the second class of chapter 6, squares and square roots. In the previous class we have learned about the concepts of squares and square roots. We have learned about its properties, we have learned about Pythagorean triplets, we have learned about how to find square roots. So now let's put that into practice now. Let's look at the exercises one by one. So let's turn to page number 96. Exercise 6.1. We will start with the first question. Squares and square roots. So we will start with the first exercise, that is exercise 6.1. You can turn to page number 69. The first question states, what will be the unit digit of the squares of the following numbers? Now they are asking us, in the first question it's 81. Now they are asking us what will be the unit digit of the squares of the following numbers. Now here we don't have to do any calculations. We don't have to multiply 81 two times. There is a shortcut method which we have already learned from the properties of squares. You don't have to do 81 into 81 anymore. But from the properties we know that if we look at the ones place, we have already discussed. Let me write this down again for your understanding. Nine, 16. Now, if we look here, if we look in these squares, we can see that the numbers are ending with 0, 1, and 4, 9, 6, 5, all the unit place. 6, 9, 4, 1, they are repeating, so I'm not going to write it again. Now, from this property, we know that if a number is ending with these numbers in its unit place, or you can say the last digit. Now, if a number is ending with 0, 1, 4, 9, 6, and 5, we know that it is a square. Now, what we're going to do is we're going to simply look at this one, make it square, which is nothing but 1 into 1. We get 1. That means when we multiply 81 two times, we will get a number and the units place will always be 1. The rest can be any other numbers. I hope you are clear with this. Similarly, for question number 2, in question number 2, 272. To find the units number, we need not multiply 272 two times. No need to do this. Simply take this, the unit place number, that is 2, and make it a square. Now 2 into 2 is 4. That means a number will come and in its unit place it will be 4. So your answer will be 4. I hope this is clear. This will be same for all the numbers. From 1 till 10, the same step. We take the unit place number and multiply it 2 times. Make it square. Whatever number we find, that will be the unit place digit. Now let's look at another example. Question number 3. Question number 3. Now there may be some instances where we get like this, 9. So 9 into 9. 9 into 9 is nothing but 81. Now we're getting here, we all got single digits only. It was easy to identify. Now we're getting double digit. We can't say that the ending will be 81. We have to know what the units place will be. So when we multiply, we get 81. That means in the units place, we get 1. That means this 1 will be in the units place when you multiply this. That means whatever number you get, the unit place will always be 1, irrespective of what we're getting here. The last digit is 1, so we will get 1 in the units place. I hope you understood this. This is for question number 1. Let's move on to the next question. Question number 2. Let me read it for you. The following numbers are obviously not perfect squares. Give reason. Now, they have given us a series of numbers from 1 to 8. They have given us so many numbers, but they have also stated that these numbers are not perfect squares. Now look here. Question number 2, 1. The first number is 1057. Without calculating, without finding square root, we have to, without finding square root, we have to say, we have to give a reason why this is not a square. Now look at the last number, units place number, that is 7. For a number to be square, let's go back to the property. For a number to be square, the number in the units place should either end with 0, 1, 4, 9, 6 or 5. 7 comes under neither, right? 7 is neither. So, because all square numbers, okay, let's say square numbers. All square numbers should end with 0, 1, 4, 5, 6 or 9. We can write because all square numbers should end with 0, 1, 4, 5, 6 or 9, and this is ending with 7, so because of this reason, this is not a square number, without actually doing any calculations. Alright, so this is the same case for all the numbers. The same thing to question number 2, 2, 3, 4, 5, 3. Just look at the last digit, unit place digit. It is 3. It's not here. That means this is the reason why it is not a square number. Now there may be some cases where, like question number 5, 6, 4. Now the argument can start here. It is ending with 0. It's here. But still this is not a square number. Why? Because for this to be a square, let's count the number of zeros. 1, 2, 3. There are only 3 zeros. When we look at zeros, it should be in pairs. That means these two are a pair. This one is without a pair. That means this number of zeros here is odd. We need even numbers only for it to be square. So this is an odd number of zeros. That is why this is not a square. I hope you have understood. Now let's move on to the next question. Question number 3. These are all basic concepts. You do not need much practice also. Now let's look at the next question. Question number 3. The squares of which of the following would be odd numbers? Now for this, I'll write all the numbers. 4, 3, 1. The next is 2, 8, 2, 6. The next is 7, 7, 7, 9. And question number 4 is 8, 2, 0, 0, 4. Now they're saying the squares of which of the following numbers would be odd. They're asking us the squares of which of the following numbers would be odd. That means if we multiply 431 into 431, will it be an odd number or an even number? Same for this. If we multiply 2 times, will it be an odd number or an even number? Same with this and this. So what we will do is, similar as question number 1, we're simply going to take this, the unit place digit, that is 1. 1 square is equal to 1 into 1, which is 1. 1 is odd. So its square will be odd. The answer after multiplying, whatever we get, it will be odd. Similarly for this, 6 square, 6 into 6, 36. This 6 is even. So it is not odd. Even means it is not odd, obviously. Similarly, 9, units place. 9 square, 9 into 9, we are getting 81. The units place is 1. It is odd. So your whole square will be odd. Similarly for this, 4 square, 4 into 4 is equal to 16, which is not odd because 6 is an even number. Let's move on to the next question. Now, question number 4. This is like a number magic number type. It's kind of a puzzle for us to solve. It's kind of a riddle. It becomes more interesting when we understand it. So let's look at the question first. Observe the following pattern and find the missing digits. Let me write down the pattern first. Now let us carefully look at this pattern given here. The first one is 11 square is given as 121. All right, we have understood this. 11 into 11 is 121. Now, 101 square. Without actually multiplying, they have given us this answer. 101 square is 10201. Please look very carefully. There are so many ways to understand this. Let me explain one simple way. Now, the next 2 zeros have come now in between the ones. First 1 0 came, now 2 zeros. Now when these 2 zeros came, 1 and before 2, 2 zeros came. 2 zeros have come. After 2, 2 zeros. When it was 1 0, 1 0 before 2, 1 0 after 2. Now here we have 4 zeros. That means since here 2 zeros and 2 zeros came before 2, 2 zeros came after 2. Since we have 4 now, we will put 4 zeros before 2 and 4 zeros after 2. Similarly here we have 1, 2, 3, 4, 5, 6. So I will write 1 and then 6 zeros and 2. After that 6 zeros. So this is your answer. It's not that you have to follow my what I've taught you. There are so many ways, different ways of understanding. It depends on the person who is looking at this question. So you can understand it in a different way. So it wouldn't be wrong, but the answer is this. So try to drill yourself and try to understand what is actually happening here. Now let's move on to the next question. The next question, number 5, is also similar. So I'm skipping that as an assignment for you to do some brainstorming by yourselves. So please take question number 5 as a homework for you to solve by yourselves. Now let's look at question number 6. Question number 6. Using the given pattern, find the missing numbers. Now this is more interesting. 1 square plus 2 square plus 2 square is 3 square. First pattern. Second pattern is 2 and 3 square plus 4 square plus 12 square plus 13 square. 4 square plus 5 square plus dash square is equal to 21 square. 5 square plus dash square plus 30 square is 31 square. 6 square plus 7 square plus dash square is equal to dash square. Now we have to look at this pattern and fill up the blanks. We have to look at these patterns and fill up the blanks. Let's look at the first pattern. 1 square plus 2 square plus 2 square is equal to 3 square. Now we don't actually have to go on adding, finding square, then add them up. That's a long, it's going to take you a long time. It'll be very tedious work. So what we're going to do is, we're going to look at the pattern now. The next pattern. 2 square became, 2 square plus 3 square plus 6 square is equal to 7 square. Now, when we compare these two, we can see that 1 square plus 2 square plus 2 square is 3 square. 2 square plus 3 square plus 6 square is 7 square. What we can notice here is 1 into 2 is this 2. Now similar, 2 into 3 is 6. Now look at this first one. 1 into 2 is 2. 1 into 2 is 2. So we are making it 2 square. The result is 1 more than 2. That is 2 plus 1 is 3. Similarly, 2 into 3 is 6. 6 plus 1 is 7. I hope you are understanding this. 3 into 4 is 12. 12 plus 1 is 3. So similarly, 4 into 5 is 20 square. 20 plus 1 is 21. Similarly, 5 into something, one number should give 30. So 5 into 6 is 30. 30 plus 1 is 31. 6 into 7 is 42. So 42 plus 1 is 43. So this, it may look challenging at first, but when you look at it properly, it becomes quite simple. You need a lot of practice for this, so do continue to practice. Let's move on to the next question. All right, question number 7. Now, without adding, find the sum. Without adding, find the sum. So they have given us a series of numbers. Plus 9. All right. They have given us 1 plus 3 plus 5 plus 7 plus 9. Now, they want us to find the sum without actually adding. We don't have to add 1 plus 3, 4, 4 plus 5, 9. We don't have to do this. We can do it in a very simple way. There is a property which we can use. That property is sum of n odd numbers is n square. N odd numbers, n square. Now, relating to this, let's have a look. N odd numbers means the number of odd numbers that we are using. Let's count. 1, 2, 3, 4, 5. So 5 is your n. So sum, if I want to add all these, you simply have to check 1, 2, 3, 4, 5. 5, that means 5 odd numbers is, so you know that 5 square is nothing but 5 into 5. See, 1, 2, 3, 4, 5. 5 odd numbers, that's why we multiply 5 2 times. We get the answer 25. Similarly, for next question, next is till 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Using this property, we can first count the number of odd numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 odd numbers, so to find this sum, make it a square. 10 into 10, you get 100. That means you add all these together, you get 100. I hope you are understanding this. The next question, I will leave it to you. Same thing, count the number of odd numbers and make a square of that number, you will get the answer. Let's move on to the next question. Question number 8. Question number 8. 8.1. The question is, express 49 as the sum of 7 odd numbers. Here itself they have given the answer. We simply have to write it down now. Just similar to question number 7. Now this is given in words, we have to write it in figures. So what we are going to do is express 49 as the sum of 7 odd numbers. So 49, I have to write as 7 odd numbers. So 1 plus 3 plus 2, 1, 2, 3, 4, 5, 6, 7. When I take the first 7 odd numbers, 1, 2, 3, 4, 5, 6, 7, if you add them up, you will get 49. I hope you understand this. It's quite simple. They have already given us the step here. Express 49 as the sum. Sum means add. Sum of 7 odd numbers. The first 7 odd numbers. So 1, 2, 3, 4, 5, 6, 7. When you add it, you will get 49. You can try adding it later on. Let's move on to the next question. Express 121 as the sum of 11 odd numbers. This I am leaving for you. Same thing, 11 odd numbers, you should add it, you will get the answer. I hope that is clear. So with that, we'll move on to the next question. Question number 9. How many numbers lie between squares of the following numbers? How many numbers lie between the squares of 12 and 13? That means 12 square, between 12 square and 13 square. How many numbers are there between these two? They are asking us how many numbers are there between the square of 12 and square of 13. That means between 2 square and let's make it simple. Let's make it simple. 1 square and 2 square. Between 1 square and 2 square, let's see. 1 square is 1 and 2 square is 4. So between 1 and 4 we have 2, 3. So 1, 2, 2 digits, right? Similarly, they want us to find how many numbers lie between the squares of these two. So for this, we have a formula. Numbers between n. N is 12 here, and n plus 1 is twice of n. All right. The numbers between n and n plus 1 is twice of n. So here we can simply solve it like this. We know that n is 12 here, already given. Now n plus 1 is nothing but 13. Therefore, to find the numbers between here, we simply have to do 2 into n, which is nothing but 2 into 12, so 24. So there are 24 numbers between 12 square and 13 square. You can write this, 24 numbers. All right, I hope you understand this. Similarly, for the next question also, it will be same. So 2 and 3, okay, I'll do 3 for you so that we can understand better. 99 and 100. So here, your n is, your n is 99 and n plus 1 is 100. All right. So you simply have to take 2n. So 2 into n is nothing but 99. 2 into 9 is 18, 1 in hand, 2 into 9, 18, 18 plus 1, 19. So this is your answer. I hope this is clear. Let's move on to the next question. All right, with this, we have come to the end of the first exercise, that is exercise 6.1. We will continue with exercise 6.2 now. Now, in the first question, find the square of the following numbers. 1. Find the square of the following numbers. The number given is 32. We are supposed to find the square of 32. Now we have done in the previous class finding squares, where we separated them, where we expanded them, So here we can expand like this, 30 plus, before we go there, we will write this as, we're going to find 32 square. So we will expand this, 30 plus 2. 30 plus 2 is 32. Now using a plus b the whole square, a square plus b square plus 2ab. Using this formula, now 30 plus 2 the whole square. Your a is 30, your b is 2. So your a 30 square plus your b is 2 square plus 2 into a is 30, b is 2 from here. A is 30, b is 2. We are simply replacing a and b. Nothing much going on here. So as already stated and learned earlier, 30 square means 30 into 30. So 3 into 3 is 9. 3 into 3 is 9. 1 0, but here is the square, that means 2 zeros will come. Alright, 3 into 3 is 9. 1 0 is given, but it is square, so 2 zeros will come. 2 into 2, 4. Here, 2 into 2 is 4. 4 into 3 is 12, and 1 0. Alright? So when you add this, 0 plus 4 plus 0, you get 4. 2 plus 0, 2. 9 plus, okay. You're getting your answer as 1024. So similarly, we can do this for the next question. Question 1, 2. The next question is 35. 35. So we have to find 35 square, which is nothing but 30 plus 5, the whole square. Using a plus b the whole square is equal to a square plus b square plus 2ab. We'll just write it below for a better understanding. A is 30, b is 5. So 30 square plus 5 square plus your b is 5 now. Plus 2 into a is 30 into b is 5. Same thing, 900. 5 into 5 is 25 plus 2 into 5 is 10. 10 into 3 is 300. Now, when you add this, 0 plus 5 plus 0 is 5. 0 plus 2 plus 0 is 2. 3 plus 2 is 3 plus 9 is 12. So you are getting 1, 2, 2, 5. So similarly for all these numbers, for all the numbers given below, you can easily find the squares using this property, this identity, this formula in short. A plus b is equal to a square plus b square plus 2ab. This makes the process of finding squares much more easier. But this may not be too comfortable to be used when it becomes a big number. But for smaller numbers, this is one easy way, a method of finding squares. Now let's move on to the next question. The next question, question number 2. Question 2. Write a Pythagorean triplet whose one member is 6. Now, we have learned in the previous class about Pythagorean triplet. Pythagorean triplet is nothing but in this form, 2m, m square minus 1, and m square plus 1. So, in the question it is given, write a Pythagorean triplet whose one member is, number 1, 6. 6. So 6 is one member here. Now we know that 2m is 6 now. 6 is this. Alright, 2m. Now from this we can find m is equal to 6 by 2. Multiply, when you take it on the other side, it will become divide. So 2 into 1, 2 into 3. Therefore your m becomes 3. Now we have m, we can find these two numbers easily. M square minus 1 is nothing but m will become 3 square minus 1. M square minus 1, 3 square minus 1. 3, 3, 9 minus 1. 9 minus 1 is 8. First part is over. The next number, m square plus 1. So it will be 3 square plus 1. So it's nothing but 9 plus 1, and you get the answer 10. Therefore, the Pythagorean triplets are first is 6, 8 and 10. 6 is already given, 8 and 10 we found out using these identities. I hope this is clear. The same thing will be repeated for the next number. Let me give you an example of the next number also. The next number is 14. To solve this, we have to know 2m, m square minus 1, and m square plus 1. We have to have this in our memory, in our knowledge. Now to begin with, we have 2m as 14. So m is equal to 14, multiply will become divide. 2, 1, 2, 7. Therefore, m is 7. Now since we know m, we can easily find m is 7, so 7 square minus 1. 7 square is nothing but 49. When you subtract 1 from 49, you get 48. Similarly, m square plus 1. So 7 square plus 1, you get 49 plus 1, nothing but 50. Therefore, 14, 48 and 50 are Pythagorean triplets. Now, this is all about Pythagorean triplet. We have already discussed about finding squares. We have already done exercises on that. Next, we learned about Pythagorean triplets, where we add two numbers of two different squares. For example, 2 square plus 3 square, and we get another square. So these are the topics that we have covered so far, and now the only topic remaining now, which we will be doing in our next class, is the different methods of finding square roots. Now I want you to go back, look at the previous videos if you have forgotten, look back, reflect, and try to understand what exactly is going to happen in the next coming exercises. So please stay tuned, and we'll meet you in the next class. Thank you, and see you very soon.